So I might not be here tomorrow.
Is this a long lesson?
No. All right, so we're gonna go a little quick through this because I'm not feeling good. If I'm not here tomorrow, if I haven't made up my mind, I will decide how badly I feel at 8 o'clock tonight.
So whatever you're feeling will be okay. Is CP24 like this?
How dare you say that?
I am. No, I feel like I'm getting a stroke.
Oh, what's this?
I get it every year, but it's my throat isn't sore, but my body. Okay. So today we're looking at horizontal stretch and shrink, and this is a number that's inside with X, and this number causes a horizontal stretch or horizontal shrink of our curves. And so we have calculators. They are very helpful, but we want to be able to figure out this horizontal stretch and shrink. So, I was going to say, if I'm not here tomorrow, I'm going to upload the same lesson. You guys are doing the exact same stuff pre-cal did. So, I'll upload the lesson that I gave them from a while ago. And you guys will just watch the video. Take the notes like normal and get the worksheet. So, you do not have to write all of this down. So, again, let's look at our calculators and see what's happening here. We have our normal sine function, which normally starts at 0 and ends at 2 pi. And then I want you to put in y2, this other function. So would you go ahead and plug those into your calculators, please? y1 and y2. What mode should you be in? Radian mode. So make sure you're in radian mode. So you should be in radian mode, and you can do like a zoom trig is usually a good zoom trig. Number 7 is a good window to be in. Oh, I actually tell you. Oh, here, look, I gave you more instructions. So sorry, let me, using the window. So if you have a Casio, then you have viewing window. And on TI, we just need to go to window. So find your viewing window or window. And we want the X values to go from 0 to 2 pi. So 0 to 2 pi, we're going to put in there for the X min and X max. And then on the Y min and Y max, we're just going to go from -1 to 1. -1 for the Y min and 1 for the Y max. If you have a Casio, let me know. You good? You got it? You got it? Okay. And then you can graph that. So our y equals sine of x, the normal curve, middle high, middle low, middle, and then, oh, what's going on with the second function there? It's 3, there's 3 of them in that same 0 to 2 pi. I didn't do it well. I didn't draw it well. But when I did it in pre-cal, I just killed it. It was awesome. There you go. Okay, so you can see what did that 3 do? Did it stretch it? It shrunk it, right? So this was a horizontal compression. Because you can see it's literally compressed like a spring. It's more tightly packed, okay? A horizontal compression. And, well, our big question then is, how many periods do we see here? 3 periods. We've got one period that stops right here. There's one. And then we have the other, one period, a second period, and then the third period of that sine function. So then the question really is, how can we determine the period for any trig function? So how long is this one period? So the normal one ended at 2 pi, right? And there's 3 of them here. So one period would be 1/3 of the 2 pi. So it turns out that if we want to find the period, this is 1/3. It's divided into 3 equal pieces. This is 1 out of the 3. So it's 1/3 of 2 pi, or we can think 2 pi over whatever that b value happens to be. Okay? So this is kind of a nice formula, 2 pi over b. We're not going to use it all the time, but it's nice when they just ask you, hey, what's the period? And we can pop it into a nice little function, a little equation there. So 2 pi divided by whatever that number in front of x is. Okay. So let's do some practicing here. Example 1, graph. And again, you don't have to write all these words. Just graph it and do it exactly like I do it. We're going to make sure we label 5 key points. Those are the 5 dots that we're going to connect. We're going to determine the amplitude, period, the vertical shift, domain, and range of the function. And of course, when in doubt, absolutely know how to graph it on your calculators. Okay. So let's start like we did yesterday. What's our midline? 0. What's the amplitude?
Oh, it's 0. It's 1.
There's a 1 always in front of this function, so the amplitude is 1. Now, I'm going to go ahead and use that just like we did yesterday. My midline is 0. And my amplitude is 1. So what's my maximum value? 1. And what's my minimum value? Good. Now the period. If I just wanted to calculate the period, it's 2 pi divided by b. So what's our b value? Pi over 2 is the b value. So we're dividing by pi over 2. That's really kind of a mess. So what can we do to clean that up? Keep, change, flip. Keep, change, flip. We do have to multiply by the reciprocal. So this is going to be 2 pi times 2 over pi. The pi's do cancel out, but we get 4. The 2's do not. They multiply. So we get a period of 4. That's very interesting. What I'm going to do today is going to lead us into what we're doing tomorrow, so it seems a little bit weird today. But we want to always think about our starting and ending points of our sine and cosine curves. And whatever's inside with x affects those starting and ending points. Our normal starting value was 0, and our normal ending value was 2 pi in that horizontal direction. This is what we did yesterday. Started at 0 and ended at 2 pi. But everything inside with x is going to modify the starting and ending points. All right? So I'm showing you this today so that tomorrow oh, we did this yesterday. Okay. Gets a little harder tomorrow. So all I have to do to figure out what goes along my x-axis or along my horizontal axis is isolate x. How do I get x by itself? Divide by pi over 2, which I don't like to do. So what can I do instead of dividing? Multiply by the reciprocal. So I'm going to multiply by 2 over pi everywhere. So those cancel out, leaving x by itself. What's 0 times 2 over pi? 0. That didn't change. Over here, it does just what we did here, which the pi's cancel out, and we're left with 2 times 2 or 4. And so these are our new starting x value and ending x value. Today, our ending value is going to match our period, but only today. That'll never happen again. Okay? So I just wanted to show this to you. I like having the starting and ending values because it makes it really clear that we're starting at 0 and ending at 4. And that's going to give me 1 period of my cosine curve. What is halfway between 0 and 4? What's halfway between 0 and 2? And what's halfway between 4 and 2? 3. Oh, 0, 1, 2, 3, 4. Hey, that's a nice little pattern. Okay. Now, what is our cosine song? High, middle, low, middle, high. Very good. And so it's not catchy enough. We need to make sure that you make sure your little tails curl back down so it doesn't look like a parabola. The domain and range. Domain is what? Negative infinity to positive infinity. And the range? -1 to 1. So, all right. Let's look at letter B. What is our midline? 0. Good. What is our amplitude? Good. What's the period? No. No? How do you find the period? 2 pi over b, and our b value is 1. Oh, that's a b value. Just kidding. 1/2, which means we need to do what? Keep, change, flip. Multiply by the reciprocal. 2 pi times 2 over 1, which is 4 pi. Yeah, over 1. Yeah. Not incorrect. All right. And again, if I wanted to do the starting and ending points, it's a good idea to get into the habit of that. Our sine curve normally started at 0 and ended at 2 pi, but every time we have a change with x, it's going to affect those starting and ending values. So again, how do I isolate x? Times by 2. Times by 2. Multiply by the reciprocal, if you will. So that we get x in the middle. What's 0 times 2? 0. And 2 pi times 2? 4 pi. And so you can see that we get those starting and ending values. And today it just matches the period. I'm going to go ahead and label my midline is 0. My amplitude is 3. What's my maximum value? What's my minimum? Okay. And I'm starting at 0 and ending at 4 pi. So what's halfway between? Now I'm doing this on purpose. I know it seems really obvious right now, but it's not always this easy. What's halfway between 0 and 4 pi? I'm saying it that way for a very particular reason, which will come to light in just a minute. What's halfway between 0 and 2 pi? 1 pi. What's halfway between 2 pi and 4 pi? 3 pi. All right. I promise there's a reason I'm doing that. All right. What is the sine song?
Middle high.
Middle high, middle low, middle. Very good. And there is our beautiful sine curve. I'd like to go ahead and show you just how to graph this to check, and also to check an ordered pair. So if you would kindly plug that equation into your calculator. 3 sine. Now, this is 1/2 x, and the Casio does interesting things when you do that, so you need to be really careful when you type this in. I think the best way is probably, this is x over 1, right? True or false? True? Okay. So then I could multiply, and I could also just write x over 2. 1 times x is x, 2 times 1 is 2. I'm actually going to type it in this way. You could do 0.5x also. X divided by 2. And what you need to do is set your window so that it exactly matches the picture that we have graphed. So go to your viewing window. Go to your viewing window, and we're going to set our x-axis from 0 to 4 pi. 0 to 4 pi. You don't need to worry about the scale too much. It doesn't matter. And then the y minimum and y maximum. My y minimum is -3, and my y maximum is +3. So I'm setting my window so it's identical to what I've got graphed. And then you can just hit graph, and it should be pretty darn close to what we saw. Very cool. But the best part is that you can use trace to check a point. So this point is pi 3. So I'm going to use trace. I'm going to hit trace and type in pi for my x value and hit enter. And there's Tinkerbell right there, and I get my output of 3. So I know that it's perfect. All right, so you can check ordered pairs really easily. I could check 2 pi just by typing in 2 pi, and it gives me an output of 0, which matches my graph. Okay. So please check your graphs. Make sure you can do that. Let's do one. Let's do one more. Let's do C. Y equals -2 cosine of 3x plus 4. Because he's listening to the lesson. What is the midline? 4. Good. And the amplitude? 2. Absolute value is 2. And I'm going to go ahead and mark that up here. My midline is 4. With an amplitude of 2, what's my maximum value going to be? What's my minimum? Good. What's the range going to be? 2 to 6. Low to high, 2 to 6. Yeah. All right. How do we find the period? 2 pi over b, which is 3, and we're done. Hey, look at that. Again, I could do the starting and ending values, which normally started at 0 and ended at 2 pi, and I could solve for x really easily by just dividing by 3 everywhere. And again, tomorrow this gets more complicated, but we get the same thing today, 2 pi over 3. So we're starting at 0 and ending at 2 pi over 3. So this is where talking, the way I've been saying things is purposeful, okay? So I've been saying every time, what is halfway between 0 and 2 pi over 3? And the reason that I've been saying it that way is because it actually translates mathematically really great, okay? So what's halfway between 0 and 2 pi over 3, okay? And if you work out the math, obviously, I know I heard the answer already, but 0 plus 2 pi over 3 is 2 pi over 3, and that becomes 2 pi over 6, which reduces to 1 pi over 3. Okay, so that one was pretty easy. If we want to find this midpoint, because that's exactly what it is, it would be halfway between 0 and pi over 3. Well, what's halfway between 0 and pi over 3? Pi over 6. And again, the math works out really well here too. Pi over 6. And then I want to find this last one. And again, what is halfway between pi over 3 and 2 pi over 3? So that becomes half of 3 pi's over 3, which becomes 3 pi over 6, which reduces to pi over 2. And I'm going to leave it 3 pi over 6. I don't need you to reduce. And in fact, if you left your answers unreduced, then you'll notice the pattern really well. So this is 1 pi over 6. Now imagine we want all the denominators to be 6. So this is 1 pi over 6. What does this become? 2 pi over 6, 3 pi over 6, and this is 4 pi's over 6. And so when everything has the same denominator, you can recognize that pattern really well, and it's a really good double check to see if you did it right. So whether you have your answer reduced or not reduced, that's fine. Doesn't matter to me. Noelle? Yes. That is another way to do it. I'm going to do it this way every time because I like the math. I really like talking about the patterns and that sort of thing. What is the cosine reflected song? Low, middle, high, middle, low. All right. Okay. Do you have any questions for me?
Oh, we're not doing
I don't know.